Hello and welcome to Lesson 2 in Proportion, Similarity, and Congruence. So now today we're going to take the concepts that we learned in our last lesson, setting up the ratios, cross-multiplying and solving for values, and using those to set up and find missing side lengths of similar polygons. Okay, so what we have to do before that, number one, define similar polygons. Number two, determine if two given polygons are similar. Once we know that they're similar, or we're told that they're similar, we can find the missing side lengths using similarity, and we can create dilations with a given scale factor. So if we know the multiplier that can stretch or shrink, we can find that scale factor and come up with the specific value that's missing. Okay, so now definitions. Okay, going back to our definitions from before, ratio is a way of knowing the relationship between two quantities of something. Okay, a proportion is an equation written in the form of stating two ratios are equivalent. And now, when we look at similar figures, figures that have the same shape, but not necessarily the same size. Okay, so we have to understand that they are not equal, but they are similar. Okay, so we can't use the equal symbol for these shapes because we can see the two M's are different sizes, but they look like each other. Okay, same thing with the Jumpman logo that we're looking at there. We can see that the logo is similar to, it is just not equal in size. Okay, so now we always have to be careful when we're looking at it because similarity needs multiple pieces to really hold true. So when we're looking at these pairs of shapes, we always want to do the eye test first. Okay, based on the eye test, are these similar? Okay, the answer to this first one would be no. Okay, why are they not similar? Okay, we can see with the yellow one, it is a lot longer than it is high. With the blue rectangle, length and width are very close together in measurement, but in the yellow rectangle, they're not. Okay, we look at our second pair. We've got a couple hexagons. Okay, looking at the hexagons, they look similar, same shape, just different size. Looking at our two triangles. Okay, are these two triangles similar? Hopefully the one thing that stands out here is this angle. We've got a 90-degree angle and an obtuse angle. So if one is a right triangle and the other one is an obtuse triangle, no, they are not similar shapes. And then our last two, we've got a couple squares. Okay, and squares are always similar to each other. Okay, so now, if we have two similar polygons, and here we're told that these two are similar, how do the corresponding angles compare? So when I'm looking at these similar shapes, angle E and angle T, angle D and angle S, the angles are always equal to each other. If you go back and look, reverse it just a little bit and look at the shapes that we looked at. All the angles had to be the same in order for them to be similar. Okay, how do the corresponding sides compare? They're not going to be equal, but they are going to be proportional. Okay, so they are going to be proportional, and that means that we can set up equal ratios and cross-multiply and solve. Okay, so now, stating the rule. What is the rule about similar figures? Two polygons are similar polygons if and only if. We need both. The corresponding angles are equal, and the corresponding sides are proportional. Okay, so we're always looking for those two pieces. So we just said, okay, we want to just have it in our simplest form. We need equal angles, proportional sides. Okay, so if we're looking through, okay, are the angles equal? Yes. Are the sides proportional? 12 over 12. Does that equal 10 over 18? Okay, we can see this is a 1-to-1 here. This is not a 1-to-1. Okay, so if you're ever unsure, set up the ratio, cross multiply and solve, and see if you get the same value. Okay, this one here. Okay, right off the bat, angles are not equal. But notice that the sides are proportional. Okay, so even though one thing is true, okay, they're not similar unless both are true. Now, let's do some solving. Okay, we can use this to solve missing pieces. Okay, now, once again, finding what we have, the most important thing that you have to do with similar figures and setting up proportions is make sure that the images match each other. Okay, in this first set, we really helped you out. We have the two, quadrilaterals. Okay, it's not really a trapezoid or anything else, but a quadrilateral. Okay, we've got our two quadrilaterals that are set up in the same proportions. Okay, so it's kind of easy to find that one missing angle because we're matching it up. Now, when we look at that missing side, what we want to do is set up our small and large ratios. And then what I'm going to do is I'm going to do the top measurement over the side measurement for both. Okay, so for the small shape, top is 21, side is 18. For the large shape, the top is X and the side is 24. We have to make sure that we set them up with corresponding pieces in the right places. And then from there, we can cross multiply and solve for the rest of this problem. So we've got 18 times x equals 21 times 24. Okay, so we just multiply that out and divide by 18. So 21 times 24, enter, divide by 18, okay, and we get our length measurement of 28. Okay, and you always want to make sure, does your answer make sense when looking at the problems? Okay, we can see that this is the small shape on the left, where this upper value is a 21. This is the large shape on the right. So we know x has to be bigger than the 21. Okay, also looking at these side measurements. The side measurement is the smaller of these two measurements. So the side measurement also has to be the smaller of these two. Okay, so when you're getting an answer, okay, just don't trust it blindly. Make sure that you look back at the picture and you can see, does this match up overall? Okay, now, here's where we really have to be careful is when we start pairing up and putting things together. These triangles are not matching each other very well right now. So what we want to do is pull them apart. And one thing I can do, to make things a little bit easier, okay, I'm going to leave A, B, and C the way it is because that is the way that it gives me the first triangle. But now I'm going to draw a similar triangle separate from it, okay, and it doesn't have to be to scale. But what it does need is it needs the matching values. So A matches with D, B matches with B, and C matches with A. Now what I'm going to do is I'm going to use the measurements over here and put them in their right spots. So DA is M, DB is N, and BA is 5. Now I've set it up properly so I can work off of my original ABC and my new triangle here of DBA. You have to make sure that the triangles are lined up with one another, otherwise you're going to run into some problems with these situations. Okay, now I can set up my proportions. Okay, and remember, you always want to just do triangle ABC for one of your proportions, and then triangle DBA for your other set of proportions. Okay, now to find M, okay, so I'm going to start with M, which is kind of like my right side value. Okay, so I'm going to go the right side of ABC is 9. The right side of DBA is M. Okay, and then I need a measurement for DBA. So I'm going to go right side over bottom. And then now my bottom of DBA is 5. My bottom of ABC is 7. So now I know that I've set it up right. I've got a proportion for each triangle, and I'm making sure that I'm putting the order of the pieces in the correct order overall. And then once I have this set up, it is a quick cross, multiply, and solve. 7m equals 45, and these numbers aren't always going to work out perfect. And then we're going to divide out 45 divided by 7 to get our answer, and look for the rounding rule of the problem. We can ask you to round to tenths. We can ask you to round to hundredths. Here I'm going to round to the hundredths on this value. So it's going to be 6.43. Now, once again, make sure that the value makes sense within the triangle. Okay, I know that this is a smaller triangle. Okay, based on the side lengths, it should be the largest side length. So it looks pretty good with respect to that. Okay, the only thing I have to do is I have to find my n value to be able to set up and solve for that situation. So now I'm going to do a new ratio to find n. N over 5, I wouldn't want to use the 6.43. It's not a perfect value. Make sure you use perfect given values when you're setting up your ratios. And then that's going to equal, the n is on the left, so I need the left value on top of my other triangle. And the 5 is on the bottom, so I need the bottom value there. And now I can cross multiply and solve. Cross multiply, 7n equals 25. Okay, once again, I have to go back to the calculator and divide that out. 25 divided by 7 equals 3.57. Okay, now once again, make sure that your values make sense in the context of the problem. Okay, I've got a 9 on the right, a 7 on the bottom, 5 on the left, so I can see that that's the order that they decrease in. So when I look at my m value, 6.43, then it decreases to 5, and n decreases again. Okay, so those values make sense based on the context of the situation. Okay, and that is our lesson for today. The big thing that you have to remember is when the shapes are not organized neatly for you, like these upper two are, you want to redraw and re-image based off of how the values are labeled to make sure you have your equal, or not your equal, but your proportional values in the corresponding spots overall. Thank you and have a good day.